grade. This is our new math standard, which is Geometry Classifying Quadrilaterals, where we are going to be breaking this up into two different standards. So when you do your PowerPoint lessons that I'm posting into your Google Math Classroom, just know you'll be answering two essential questions for this standard. The first part is to classify quadrilaterals into categories based on their properties. And then the second part is to explain that attributes belonging to a category of quadrilaterals also belong to all subcategories of that category. I don't know if you can see that, because I don't have my helper today. So, if we were to journey into this standard as a class, what we would need to be doing first is to hit some prerequisite vocabulary that are geometry related. So I actually introduced that into your PowerPoint first, just so that you, when you were talking about how a parallelogram has two sets of parallel lines and is a type of quadrilateral, which is a four-sided polygon, you're going to know what those terms mean, because you did cover those, or you should have covered those in your previous grade levels. And really, fifth grade standard for classification of quadrilaterals is really kind of leveling it up and understanding how one shape can belong to multiple subcategories, and then all those subcategories above it actually can be used to describe that shape. And we'll talk about that in a second. So first, let's go ahead and give ourselves some mnemonics that we're going to need for our vocabulary. I always liked that Polygon song that is on I think it's Just Have Fun. Anyways, it's in the Google links. So if you want to listen to that, you can. And that's a really good little term in there, that a polygon is a shape with lines that connect. The number of sides tells us the name of the shape. So if you want to remember that, it's got a nice little rhythm to it, that will help you to classify what a polygon is. So when we're talking about quadrilaterals, they're four-sided polygons. You'll know what polygon is, because you would have learned that in previous grade levels. Another one is equilateral. And I always remember this because of the name, and then I made little equal signs like this. I hope you can see that. So we used to say in class, equilateral equals all sides the same, because equivalent means the same for everybody. So equilateral equals all sides the same. A polygon is a shape with lines that connect. The number of sides tells us the name of the shape. The other one is right angle. You need to know what a right angle is. I used to remember this back when I was a middle schooler. It was very, very popular to talk kind of like a valley girl. So people would be like, oh my gosh, you are so right. I cannot believe that she did that, Teresa. You would not have believed it if you hadn't seen it in your life. Oh my goodness. And so when people used to talk like that, it used to remind me of, they used to say, oh, she is so right. She is so right. Just get, yes, you're so right. So I used to remember this when I was a kid, that a 90-degree angle was like one arm out and one arm straight up. And then you would say, 90 degrees, oh, so right. Because it just made me think of what they used to say all the time. Oh, you're so right. So 90 degrees, oh, so right. So you can kind of say it with that little bit of an accent there. Congruent. And this one I kind of made up just because it rhymed. And you know how mnemonics work. If you can associate them with something else, they stick in your brain and make those neuron connectors a little bit thicker so that you can recall that information again later. So congruent. This is what I said yesterday. So you knew it. Congruent. Same size and shape will do it. So almost like a cheerleader, kind of continuing that Valley Girl sort of sound of the 90 degrees, also right? So again, you knew it, congruent, same size and shape will do it. So it helps you to remember congruent. So you can kind of use your hands as a model for that. Two hands, they look almost exactly alike. They'd be the same size and same shape. So congruent just means same size and same shape. Parallel lines, like railroad tracks. The lines go on and on forever, and they go on forever without intersecting. So I used to remember that movie, Emperor's New Groove, where the llama the emperor gets changed into a llama, and he's like, "Hey, no touchy." So I used to say with my students, "Okay, so parallel lines, they no touchy." And the other one is perpendicular. So perpendicular lines, they actually intersect in a way that they form 90-degree angles. So if you can imagine little tiny square boxes in the corners, that would make 90-degree oh so right angles. So we used to say parallel lines, no touchy, perpendicular, intersect. So we'll start from the beginning. A polygon is a shape with lines that connect. The number of sides tells us the name of the shape. Equilateral equals all sides the same. 90 degrees, oh so right. Congruent, you knew it. Congruent, same size and shape will do it. Parallel lines, no touchy. Perpendicular, intersect. So those are some prerequisite vocabulary that'll give you some mnemonic help so you can answer those questions later on. So when you do your PowerPoint presentation lesson, you're going to be doing a matrix, just like, sort of like mine, where you're going to have the vocabulary terms. You're going to have to write in the definition in your own kid-friendly terminology, and then you're going to have to illustrate. I highly recommend you using a ruler. I will try and send one home in each of your packs this week, or for week 3, I should say. Because if you don't use a ruler, it's going to be really crooked, and you're going to have to white out or erase a whole bunch. So it's very helpful if you use a ruler to make everything super pretty and nice. And one of the things that I really wanted to talk to you about before you hit that second essential standard is what it means when you are classifying quadrilaterals into those subcategories, realizing that those attributes belong to a category and a subcategory. So I wanted to give you an example of what that looks like in a non-geometry sort of way. So this is what it looks like in geometry. Aw, ooh, I just ripped that. Here's what it looks like in geometry. Breaking up quadrilaterals into trapezoid, that can become a parallelogram, that could be a rectangle, or could be classified as a square. If we were to classify this into subcategories using where I am, and you'll see this in your PowerPoint slides, I did a little bit different example, but where I am right now. So I am in the Milky Way galaxy. You are here. I am on Earth, the 3rd planet from the sun. And don't laugh at my drawings because you know that I don't always do that so great. I am in North America. I am in the United States of America. I am in North Carolina. So you can see, hopefully you can see, I'm not even sure if you can even see because I don't have my video helper. So you can see as we break it up into more and more specific subcategories, just because being in North Carolina is the most specific of all of these categories, it doesn't mean that I'm not here just because I'm here. This is the most specific description of where I am. But being I'm in North Carolina, I am also in the United States. Being I'm in the United States, I am also in North America. And being I am in North America, I am also in Earth. And being I'm in Earth, I am also in the Milky Way galaxy. So this subcategory of being in North Carolina, I also can apply that same information to the previous category, because North Carolina belongs in the U.S., and the U.S. belongs in North America, and North America belongs on Earth. So when we do our classification of quadrilaterals, that should help you to understand a little bit more when they're breaking something down into more and more specific categories, that just because you're being super specific with one category doesn't mean that the subcategories before it don't apply, because they do, especially if you're looking at shapes which can fit more than one category criteria, like a square, for instance. A square can actually fit the criteria for a rectangle. The square definition can actually fit the criteria for a rhombus. So you'll actually see that breakdown when you go through your PowerPoint presentation. I also gave you another example in there with animal classifications. If you were to classify a human being, you start with the broadest category, kingdom, and then break it up into the phylum, class, order, family, genus, species. And again, each one of those subcategories, previous subcategories, also applies to this very, very specific category. Because if you are a Homo sapien, you are also in the genus Homo. If you are in the genus Homo, you're also in the family Hominids. And if you are in the Hominids, you are also a primate, which is also a mammal, which is also in the Chordata phylum, which is also in the animal kingdom. So you can see that each one of these subcategories also meets the criteria for the category before it. So if you're a Homo sapien, you are in the animal kingdom, and you have a spinal cord, and you also are a mammal. So it's just getting more and more specific. So Homo sapien is the most specific description of a human being, but all of these previous subcategories also apply. So that kind of gets it in your mind what it is when we're looking at the classification of quadrilaterals. It's not just identifying what's the shape? It's a square. What's the shape? It's a kite. What's the shape? It's a parallelogram. But it's really getting into the analysis of what it means to be each of those shapes, looking at those characteristics that classify that shape to make it what it is, and to draw connections and that higher order thinking of what criteria would that also apply to with these other shapes. So it's a lot of comparing and contrasting, which is a great ELA connection. So when you're filling out all of your distributive summary pages, those quick summaries, that's where you're really going to be doing a lot of brain processing. So make sure that you fill all that out on your sheets so that I can see what your thoughts are, and I'll be able to tweak and kind of drive you in the right direction if you're getting a little off-road. So if you have any questions, please don't hesitate to give me an email, a phone call, or dojo me, or message me through Google Classroom. I hope you're all doing really well. I miss you so much, more than you can ever imagine. I hope you're having a great day. Mwah! I'll talk to you soon.